Hi everyone, my name is Nithin and welcome back to PSLE Science, where I'll be going through heat energy important questions today. And I do hope you have watched my previous video on heat energy, because it will help you to understand my explanation for these important questions today. Okay, let's get started. Okay, for the first segment of this video, I am going to go through questions on evaporative cooling. So let's take a look at it. Okay, for questions on evaporative cooling, there are two types of questions. So the first type of question is sweating to stay cool. So in this first type of question, there's actually two scenarios. So let's take a look at the first scenario. The first scenario is without the fan. Let's take a look at the question. How does sweating help our body to stay cool? So there's no fan, okay? So let's take a look at the answer and I'll explain from there. Water in sweat on the surface of the skin would gain heat from the body to evaporate, causing the body to lose heat to the water and stay cool. Okay, do you remember the HPC structure that I went through last video? So the HPC structure is basically HPC. H stands for heat gain or heat loss. Okay? And P stands for process. And there are 7 processes, right? Remember? And C stands for change in state or volume. Okay, for this question, there is no change in state or volume. So I'm going to kick this out. So I'm going to focusing on these two only. So identify which are the H and P. So the H is over here. So basically before that, something important is that you need to state water in the sweat. You can't just say the sweat evaporates. You need to say water in the sweat on the surface of the skin. Okay, so this is the H. Would gain heat from the body. Okay, so this is H. So gain heat from the body. So let me just write H on top. And next, to evaporate. This is the P, process. So the process is evaporation, okay? Next, there's another H over here, causing the body to lose heat to the water. So these two words are very important, from and to. So if you're losing heat, you are losing heat to something. And if you're gaining heat, you are gaining heat from something. So this is how you answer it. So this is another H. And we must link back to the question. So we are saying stay cool. Okay? So I hope you understand that. Now let's move on to the second scenario, which is with the fan. Okay, let's take a look at the question. Okay, the question is, how does standing in front of the fan help our body to stay cool faster? So there is a comparison term over here, faster. So in our answer, we should include comparison terms as well. Okay, let's take a look at the answer. The presence of wind from the fan causes the water in sweat on the surface of the skin to gain heat faster from the body to evaporate faster, causing the body to lose heat to the water faster and stay cool faster. Okay? So why is this important? Because right, first you need to understand the 3 factors of affecting the rate of evaporation, because they are asking for faster, right? So you need to know what causes the evaporation to become faster, because only because of the evaporation our body is staying more cool. Okay, so remember this acronym that I've taught you in my last video, WET, wet. So wet stands for W is wind. So I'm talking about presence of wind over here. Then E stands for exposed surface area and T stands for temperature. Okay, so the presence of wind from the fan causes the water. Okay, do you realize something? From this part onwards, the whole answer is the same, right? So the water in the sweat, but there's a difference. We are including the word faster wherever we can. because there is a comparison term over here, so we need to use this comparison term in our question, in our answer as well, so that we can identify that there is a change. Because if we don't explain the word faster, then there is no difference to this question over here. So that is why you need to use comparison terms when a question asks for comparison terms. Okay, so let's move on to the second type of question. Okay, the second type of question is the Miss Fan question. Okay, let's take a look at the question. So this is the question. How does the Miss Fan cool the surrounding air? Okay, so this is the Miss Fan, okay? So the fan actually blows the wind, right? And this wind actually disperses the mist that comes from the fan. So this is how the mist fan works. Okay, so let's take a look at the answer. The wind from the fan disperses the mist over a large surface area. The mist then gains heat from the surrounding air in order to evaporate, causing the surrounding air to lose heat to the mist and decrease in temperature. This helps to cool down the surrounding air, allowing people in the area to lose heat faster to the surrounding air to cool down faster. Okay, do you realize something? That the temperature difference that I taught in the last video is coming back into this question where we apply it. So let me just highlight the important points of this question and explain it to you. So the wind from the fan disperses the mist over a large surface area. This is very important because only after you explain this, then only you can explain about the people becoming cooler. So the mist then gains heat from the surrounding air in order to evaporate. So there's a H in a P over here, causing the surrounding air to lose heat to the mist and decrease in temperature. So this is the cause. So this is the outcome, decrease in temperature. So it lost heat to the mist, the surrounding air lost heat to the mist and decrease in temperature. This helps to cool down the surrounding air because it decreased in temperature. And if the surrounding is cooler, we also feel cooler, right? So the people in the area to lose heat faster to the surrounding air to cool down faster. So this is why the mist fan helps us to cool the surrounding air and helps us to stay cool as well. So this is how the mist fan works, and you can clearly see that the temperature difference is working over here. Okay, so now let's move on to the next question. Okay, so for the next segment of this video, I am going to go through questions on water droplets formation. Okay? Okay, so for questions on water droplets formation, we need to first know the steps to take. Okay, so what are the steps to take? So step 1, we need to identify the sources where the warmer water vapor could have come from. So it's either the water vapor from the surrounding air gains heat from the heat source to become warmer, or the water from the warmer object evaporates to form water vapor. Okay, to form warmer water vapor. So it's either one of this. And then for step 2, we need to recall the condensation template answer for the formation of water droplets on a cooler surface. So this is the template answer. Warmer water vapor from the source comes into contact with the cooler surface of the object, loses heat to it, and condenses to form water droplets. So all these blanks, right, is basically we need to apply it into the type of question. So if we have the source, right, from the surrounding air, comes into contact with the cooler outer surface of the glass, loses heat to it, and condenses to form water droplets. So you can say something like that. Okay, so now after this, we need to go to the next. So now that you know that what are the steps to take, now we can move on to the questions. Okay, so this is the first question. So this type of question is basically on hot buns and water droplets. Okay, So let's read the question. James placed some hot buns into a box and noticed that they become soggy after some time. Explain James' observation. Okay, so first let's visualize the box. Okay, so the box something like this, right? Okay, so let me just draw it first. So the box has a lid as well. Okay, I know my drawing is not that good, but just deal with it. So these are the hot buns, okay? Okay, so these are the hot buns in the box. So he noticed that they become soggy after some time. Okay, so let me go through the question while I update this drawing. Okay, so for all situations, you need to know how to visualize the question. Okay? Okay, now let's take a look at the answer with the step-by-step approach. Okay, so for step 1, what do we have? The warmer water vapor in the box gained heat from the warmer buns to become warmer. So this is where we identify the source. Okay, so the warmer water vapor in the box gained heat from the warmer buns to become warmer. Okay, so this is how the water vapor becomes warmer. Now for step 2. Before that, let's update our drawing. So imagine there's some water vapor here, right? And then they gain heat from the buns. Okay, just imagine that gains heat from the buns. Okay, now for step 2. The warmer water vapor then rose because it's warmer, right? So it rose, okay, rose up and came into contact with the cooler underside of the lid, lost heat to it, and condensed to form water droplets. Okay, so it condensed to form water droplets. Okay, so I hope you understand that. Okay, but this is not the answer yet, because we are missing the point of how they become soggy after some time. So then we need to link back to the question. Okay, so basically what we need to say is that the water droplets dripped onto the buns, causing them to turn soggy. So basically the water droplets over here, they went down and dripped down. Okay, they dripped down onto the buns, and then the buns, right, they become soggy. That's why this is how you answer the question using the steps that you need to take. But of course in the exam you don't say step 1, step 2 and link back. You need to write it as one paragraph. Okay, now let's move on. Okay, so this is the next question. So this type of question is on the ice cream box and the white fumes. So this question has 2 parts to it. So let's read part 1 first. White fumes were observed around the ice cream box. Explain the formation of the white fumes. So this is the ice cream over here, ice cream box, and these are the white fumes on top of the ice cream box. So they're asking us to explain the formation of the white fumes. Okay, let's take a look at the answer. So before the steps, we need to state this sentence, which is the air around the ice cream box lost heat to the cooler ice cream box to decrease in temperature. Okay, so this is the first part we need to say. So after it decreases in temperature, then we can talk about the step 1. Then the warmer water vapor from the surrounding air, step 2, came into contact with the cooler air around the ice cream box. So this decrease in temperature, right? So it turns cooler, this air over here. So it came into contact with the cooler air around the ice cream box, lost heat to it, and condensed to form tiny water droplets. But this is not the end of the question yet. How does this form white fumes? Okay, so we need to link back and we need to say forming tiny water droplets forming white fumes. Okay, so I hope you all know that tiny water droplets are actually the clouds. Okay, so you need to remember this. So this is how we are linking back to the question, forming the white fumes. So next, let's move on to part 2 of this question. Okay, so let's move on. Okay, So this is the next question, okay? So this is the part 2 of this question. So let's read it. After some time, a layer of ice was observed on the outer surface of the ice cream container. Explain how the ice was formed. So first, we need to explain that the warmer water vapor from the surrounding air next came into contact with the cooler outer surface of the ice cream box, lost heat to it, and condensed to form tiny water droplets. Okay? So why is that so? So on the outer surface of the ice cream container, right? So the warmer water vapor from the surrounding air came into contact with the cooler outer surface of the ice cream box, lost heat to it, and condensed to form tiny water droplets. So why is this so? Let me explain. Okay, now this is because, right, you need to understand the concept of this. So how is ice formed? So it can either be from liquid, it can only be from liquid to solid, right? But in this case, it's being from gas to is turning into liquid, then it is turning into a, after the liquid, then it is turning into a solid. So this is why after step 2 we need to say the water droplets then continue to lose heat to the cooler ice cream box. So at this point, right, when it's continuing to lose heat, right, it's actually at the state of liquid. Okay, and warmer water vapor, right, water vapor is actually a gaseous state, so over here is gas, and after that it freezes and forms ice, and ice is actually a solid state. So this is how we explain the slow progression of the ice formation. Okay, so now let's move on. Okay, so now we have the third type of question, which is the foggy spectacles question. Okay, so I think this actually came in the PSLE question once. So let's take a look at this question. Sam took a bus to school. When he got off the air-conditioned bus, okay, they're giving us information. Let's just highlight it. Air-conditioned bus. They're telling this for a reason. Okay? Because if not, they will just say normal bus, right? He noticed that his spectacles has turned cloudy or foggy, anything can, causing his vision to become blur. Okay? So we need to explain his observation. Okay, so before we say the steps, right, we need to state this statement first. In the bus, Sam's glasses lost heat to the cooler air to decrease in temperature. Only after we explain this, right, when it decreases in temperature, then we can go on and talk about the water vapor, identifying the source. So when he got off the bus, the warmer water vapor from the surrounding air, because his spectacles are already cool, right, so if not, they will be equal. Before he got into the bus, right, his spectacles and the water vapor were equal. The water vapor were at equal temperature. That's why his glasses did not turn foggy before he got into the bus. But after he came out, right, his glasses are actually cooler than the surrounding air. So when the surrounding air actually comes into contact with the cooler surface of his glasses, right, it loses heat to it and condenses to form tiny water droplets, and these water droplets are actually the fog. So this is causing his glasses to turn foggy. Okay, so this is how we explain this question. Okay, so this is how we explain and answer. Okay, now let's move on. Okay, so for the fourth type of question, we have the cloudy mirror question. Okay, so let's take a look at it. Okay, so let's take a look at it. So question 4. After taking a shower with a warm water, Sheikh observed that the surface of the mirror became cloudy and was unable to see himself in the mirror clearly. Explain his observation. Okay, so he took a shower with warm water. Okay, so this is information. We need to highlight this with warm water. Okay, Sheikh observed that the surface of the mirror became cloudy. Okay, and he was unable to see himself clearly. So he was unable to see himself in the mirror clearly. Explain his observation. Okay, so for step 1, what we need to say is that the warmer water vapor from the shower evaporated to form water vapor. Okay, you guys also have this incident before, right? When you're showering in warm water vapor, in warm water, they're actually, right, the mirror, right, you can see like it starts to fog and becomes cloudy and you can't see yourself. You can only see the blur image of yourself, right? So this is what happened to shade as well. So how do we actually explain this? So this is an application based question as well. So we need to explain this. So first we say the warmer water vapor from the shower evaporated to form water vapor. Okay, next we need to say this water vapor came into contact with the cooler surface of the mirror, lost heat to it, and condensed to form tiny water droplets, causing the mirror to turn cloudy. Because it's the same explanation as the before question, the mirror was at a cooler temperature. That is why when it came into contact, it turned cloudy. Okay, this is how we explain this question. Okay, so now let's move on. Okay, so for the 5th type of question, we have hot water with the sealed Ziploc bag. Okay, let me go through this question now. Okay, so the question is, Sam predicts that there will be water droplets form on the underside of the container. Do you agree? Okay, so this is the image over here. Okay, so Sam actually predicts that there will be water droplets form on the underside of the container, like this over here. He predicts it. Okay, so you have to explain, do you agree? So this is a sealed tank and this is a sealed Ziploc bag. Okay, so our answer would actually be yes. Do you know why? It's just like the foggy mirror and stuff. You know, right, the water vapor over here inside the box that we cannot see, so I'm just representing it by some red dots. Okay, will actually gain heat from this water over here. Even though it's inside a Ziploc bag and it's sealed, it can gain heat because the surrounding air around it will already be hot. You know, like just like your tea or something, right? When you're drinking, right, even when it's sealed, right, even when you close it, right, you can still feel the warmth around the container and stuff, around the cup or the mug. You can still feel it. So that's why we can say yes as our answer. So now we start the step 1 of explaining. So step 1, the water vapor from the air in the container would gain heat from the hot water in the Ziploc bag to become warmer. Likewise, I said. Now for step 2, and then the warmer water vapor that just gained heat from the Ziploc bag would then rise and come into contact with the cooler underside of the container. It loses heat to it and condense to form tiny water droplets. Okay, so it loses heat to it and condense to form tiny water droplets. And this is how we explain the formation of water droplets. Okay, now for the 3rd segment of this video, I'm going to go through the question on expansion and contraction using the HPC structure. So there's only one question that I'm going to go through. Okay, so this question is on expansion of air in a bottle. Okay, so let's read the question. What caused the cork to pop out? So this is the cork. Okay, the cork is in the bottle. So basically there's a heat source over here which is heating the bottle, and after some time, right, this cork actually popped out. Why? Okay, so expansion is basically when molecules expand. Okay, so when they expand, right, they are actually the same volume, but actually they contain more space. So basically they are more far apart. So this is the expanded version. And then, right, before expansion, they look something like this. they are very closely packed to each other. So after expansion, they are very far packed to each other, even though there's the same number of molecules. Okay, so maybe I should erase this part over here so that it will become the same number of molecules. So before this, they are closely packed to each other, and after that, right, they are actually packed further away from each other. So they contain the same number of molecules, but it's just in a bigger space. Okay, so this is expansion, and contraction is the complete opposite, from a bigger space to becoming a smaller space. So expansion happens when you heat an object, and contraction happens when you cool an object. Okay, so I hope you understand this thing that I've just taught you. Okay, so we need to use the HPC structure to answer this question. Okay, so how do we use it? So for H, before we do that, the air in the bottle, then we use H, gain heat from the flame, then P, to expand, so this is the process, C, an increase in volume, so it increases in volume. Okay, after that we need to say the warmer air then rose and pushed against the cork, causing it to pop out. Okay, so basically, right, there's water vapor inside, right, which is just normal. Okay, so this water vapor actually gained heat from the flame, then it actually rose, and then it pushed against the cork, and then it popped out. Okay, so this is how it happens. Okay, so I hope you have understand whatever I've taught you today, and please do take note of heat energy because it is a very important topic and most students cannot understand this topic fully. So please do watch my previous video on heat energy and revise the questions that I've taught you in this video. Thank you and goodbye, and I'll see you in my next video. Bye.